Welcome to our program on the restoration of two riverfronts in Massachusetts. I am Eileen Gladstone with GEI Consultants. I will be your host and moderator for today's panel. We will be presenting a short summary of the two projects we will be further discussing, and then I will be joined by our panelists. I'd like each of our panelists to introduce themselves this afternoon. Illusion?
Thank you, Eileen. Hello, everyone. Glad to be here today. I am Varuj Hagopian, a waterfront engineer with 45 years of diverse national and international experience. And currently, I am a senior associate at GI Consultants, Inc. Thank you.
And my name is Dwight Dunk. I'm a principal at Epsilon Associates. I'm a wetland ecologist and permitting specialist with over 30 years of experience in the coastal and inland environments. And on these projects, I assisted with environmental permitting and initial planning.
And I'm Travis Sumner, principal and co-founder of Sumco Eco Contracting, here to give contractors' perspective to these couple projects. Thanks, everyone, and thanks, Eileen.
I'd like to give a brief summary on our first project, which is the Senator Joseph Finnegan Park at Point Norfolk in Boston, Massachusetts. This is a 14-acre former industrial property that's owned by the Massachusetts Department of Conservation and Recreation, DCR. This was an industrial property that had sat vacant for more than 2 decades, and it was also a contaminated site. DCR and also the community was committed to not only cleaning up this last piece of waterfront, was committed to cleaning up this waterfront park and also linking it to the 5-mile Neponset River Greenway, which provides a variety of scenery from urban wilderness through a mill village to a salt marsh at the mouth of the Neponset River. The existing conditions of the park before we started the renovations was a contaminated site with oil contamination and PCB and metal contamination. And along the riverfront, there was a dilapidated timber wall, and the site was overgrown with invasive plants, and the shoreline was full of debris and steel shavings. So from this old site, the plan was to create a park that would lightly sit on the land and blend with its coastal environment. The goal was that the mudflats would merge in with a low salt marsh, which would then transition to a high salt marsh, and then the coastal field would be recreated into a passive recreational park. The key design features for the park was to remove the debris, the invasive plants, the old concrete foundations, and the pulverized asphalt. We did hotspot removal of the contaminated soils. We retrieved granite blocks from dilapidated seawalls for their reuse, grading the site so that it would positively drain towards the river. To stabilize the shoreline, we used hybrid construction, which combined the granite blocks with a living shoreline. We also restored and expanded the salt marshes. The park lawns were planted with native grass and wildflower species chosen to be wildlife friendly, low maintenance, and drought resistance. The design incorporated green space capable of absorbing the floodwaters and the rising water levels. This is a photo of the construction of the living shoreline, and now you see the growth of the living shoreline just 1 year following its installation. And what we have now today is a beautiful passive park along the Neponset River, which is enjoyed by the neighborhood and residents of Boston. The other project that we will also be discussing today is the Merrimack Riverbank Stabilization Project at Wellman Avenue in Chelmsford, Massachusetts. This project was the restoration of 4,000 linear feet of severely eroded embankment along the Merrimack River. A sewer line runs parallel to the Merrimack River, and that sewer line serves a condo complex of about 700 units. And as the result of severe erosion during a number of intense storms, a portion of the sewer line was exposed, and there was the threat that it could break and put raw sewage into the Merrimack River. The town of Chelmsford partnered with the condo association to stabilize the eroded riverbank. As you can see, the existing conditions were severe. The erosion exposed more than 4,000 feet to these conditions. There's also a very sensitive ecological area. There are bald eagles nesting areas, and the river supports endangered species such as sturgeon. So as you can imagine, there were significant challenges, not only in the design of a solution, but also its construction. We evaluated a range of solutions, including moving the sewer line, which really was not feasible. We ultimately selected a hybrid solution of combining a bioengineered bank stabilization that had native vegetations on the upper portions of the reach, and below that with 3 to 5 rows of natural core logs. And then we installed a stone sill at the toe of the slope for it to be stable. As I said, there were many challenges in constructing this solution. We needed to work in the river, which, as you can see, often the river was at very high elevation. That's actually a man standing in the river trying to put down geotextile. Creating the toe sill also had many challenges, and work had to be done from the water side. We also worked throughout the winter to keep the project moving and to meet some of its key schedules. You can see the construction proceed through the winter, installation of the rock sill, and then the planting of the living shoreline along its banks. We laid down the core line, the core logs, and then did our plantings. The plantings grew over time, and now we have a completely stabilized shoreline. Again, I think what you can see visible is the sill, the core logs that will be vegetated once they're fully grown in, and the vegetation on the higher elevations. And a very impressive project. As I said, this was almost 4,000 linear feet. And that is our two projects that we will be discussing this today. And I would now like to invite the panel to come and join in our conversation.
So welcome all of you.
Thank you.
So I think my first question is to you, Dwight. Let's talk about the funding for each of the projects first. For the Merrimack River, this was a public-private partnership, and which was a key element of getting the project underway. Can you tell us a little bit more about the grant application process?
Sure. Thanks, Eileen. The condominium complex that owns the sewer along the riverbank has been monitoring the bank erosion over years. The 2006 storm that occurred over Mother's Day weekend, there's over 6 feet of bank loss in some of the sections bringing the separation between the sewer and the top of bank within 6 to 10 feet in its closest locations. So, you know, there was a risk there that damage to the sewer line during a flooding event, during an erosion event, could cause the discharge of raw sewage into the river. The condominium association teamed with the town of Chelmsford to pursue a FEMA hazard mitigation grant, flood hazard mitigation grant. That request was done because of the potential damages to the environment from an erosion event. That process started about 2011, 2012 to pursue the hazard mitigation grant. That grant program is for local communities, governments, tribal governments, and nonprofits to secure grants from FEMA. It's a 25-75% match, where the town pays 25% and FEMA pays the other 75%. In this case, the condominium association was a sub-applicant to the town, and they are reimbursing the town for the full 25% that the town is responsible for. And you know, basically it was a partnership, like we said, between the condominium association working with the town to pursue this federal grant, and it had worked out. It's worked out very well. One of the issues is timing. It, as I mentioned, it started around 2011. By the time the grant was finally contract was finally signed, and then things started beginning. It was about 3 or 4 years before it actually started design. So that's just one of the things to think about when we're pursuing grants for projects. And in terms of the funding, you could see that one of the concept plans that Eileen showed for the bank stabilization, there are some other changes during the final design, but Travis, maybe you could tell us a little bit about some of the adjustments made to construction to stay within the finite budget of the grant funding.
Yeah, certainly. Obviously, going into the project, we had a design GEI put together, which had to be modified slightly just to account for that 3 or 4 years worth of time between having the original design done and us hitting the ground, us being on site. So just some value engineering. We adjusted some of the design for a couple of reasons. One is accessibility. As you said, there was 1,200 trees that came down, but all of our work happened from within the river. We couldn't clear the entire riverbank. That was bald eagle habitat. And so we worked from within the river and had to make some adjustments to be able to do that. So we ran heavy equipment in the river on the edge and dealt with high water. But all considerations that were taken into account as we were working through the project and working with GEI to make those adjustments to allow for constructability.
Thank you, Travis. Now let's talk about the Neponset River project, which it took a lot of political will to get that underway and completed. The master plan was developed in 1998, and the site was part of the master plan for the Neponset River. It had been abandoned for decades, and all of this combined was a 40-year endeavor. Dwight, how does the Neponset River project integrate into the master plan for the area?
Sure. Thanks, Eileen. This park master plan, I've been involved with since the late 90s. I worked on the master plan, and actually I grew up in the area, so I'm familiar with the Neponset River and the surroundings for my entire life. The predecessor state agency was the Metropolitan District Commission. Eileen mentioned the current agency is the Department of Environmental Conservation and Recreation. The MDC started acquiring lands along the Neponset River in the mid-1980s, acquiring brownfield sites for the ultimate restoration of a linear park system along the Neponset River. The idea is to have a linear park extend from Boston Harbor to an area called the Blue Hills, which is about some 10 to 12 miles southwest of the city. And so this has been envisioned for many decades. The actual Lower Neponset River Master Plan and Greenway plan was developed in the late 1990s, with the master plan developed in 1998. And as I mentioned, the idea is to have a linear park system with a multi-use trail along that 10 to 12 miles of the river. And along that area, have these parks to allow access to the river and connected by the greenway. Some of the parks, such as this, are more passive use parks with restoration. Other parks are more active use with athletic fields and those types of uses. So this has been, as I mentioned, probably about a 40-year planning effort by the state, with the active planning being about 20 years. And elements of this master plan are still being constructed. But as Eileen mentioned, this is the most seaward park and kind of the last of the largest parks that's part of the system.
Well, and you know, as a Boston resident, I can attest to how wonderful this park is. I've biked along it, and my kids have played soccer on it. So it really has been a real asset to the community.
It's been a wonderful change from these dilapidated brownfield sites to green fields. It's a wonderful transformation for the river.
It certainly is. And so, Varujan, how does the design of the Neponset River project account for sea level rise? And how does the Merrimack River project account for changes in the river hydrology?
Thank you, Eileen. As you heard so far, how the funding for both projects came together. Once that gets put together and we are ready to move, what do as a client? You call a good engineer. That's why I'm here. So I want to give you the differences between the two projects. One is a coastal estuary river, and the other one is a freshwater that runs off from the very large watershed. And there was each one had challenges, and I would like to preface that for you. The Merrimack River, since the beginning, we had specific criteria to minimize the impact on the existing trees. So automatically that sent us into the notion that we need to construct this edge and do it from the water side. Versus the Neponset River Park, the Neponset River is contaminated river. The sediments are contaminated. So therefore we didn't want to get into the contaminants, and we had to construct the project from the upland side. So they're two different approaches. Both have different hydrological situation. In the Neponset River, it's going to be faced with potential sea level rise in the future. And as a result, any design we had to do, we had to incorporate that rise into it. It could be 2 feet in the next 50 years, or it could be as much as 6 feet in next 50 years. So we designed the entire project that can flood, and after the water retreats, the park can be went back and reused. We started with the salt marsh, we went into the high marsh, and we went into the upland area. Versus the Merrimack River, it's a riverine environment. And of course, if you get a heavy rainstorms, the area gets flooded, and river elevation can jump as much as 10, 15 feet in a matter of a week. So because we were forced or directed to design the river protection, and we had to build it from the riverside, so we came up with this idea of building a hybrid system. And the system included designing a robust river rock sill that has many functions. First, we had to protect the new soft material that we were going to go on top of it, because we were concerned during ice flow in the winter and in the spring. When the ice flows and breaks up and it hits the soft edge, it can just destroy it in a matter of days. So we designed that, and at the same time, that rock sill was useful to allow Sumco to get their equipment and be able to build the edge from the water looking towards the upland. Similarly, the Neponset River, we designed it in a way we'll be able to build it from the top down. So we had some dilapidated material, we had dilapidated bulkhead. We didn't pull those materials out because we were concerned if we pull them out in the process of doing that, we can release the contaminants back into the water column. So we cut them flush at the mud line and we continued to build the edge from the bottom proceeding into the top. So that gives you a little bit an idea of the differential between the two challenging projects. Thank you.
Well, a key element of the Neponset project was the expansion and restoration of the salt marsh. It comes with both construction and permitting challenges. Verujan, how did that impact the design?
It did. Any design that you approach at the beginning, you have some ideas, you put some alternatives together, and of course, you're going to have to work with the regulators to be able to go ahead and implement it. And of course, not the very first idea that you would like to implement always materializes at the end. It's a give and take with the regulators. And if you work in partnership with the regulators, they will have their input and you have to take consideration for that and you proceed. I was
going to say, Dwight, can you comment on some of the permitting negotiations?
Yes.
Sure.
When it comes to permitting, we look at these projects and they are, projects that are restoring damaged or dilapidated environments, brownfields or eroded riverbank on the Merrimack. And one would say that those are, improving the environment. So the permitting process should be a breeze. However, both of these projects involve work within well-regulated areas that are subject to federal laws and regulations, Section 404 and Section 10, the State Wetlands Protection Act, the State Waterways Protection Act, and Section 401 of the water quality certification, Section 401 of the Clean Water Act. So we still have to go through the full gamut of permitting. And with that, we look at alternatives analysis, which Verujan alluded to, of looking at the different designs. And we still have to show that the projects meet the performance standards for these regulatory agencies. So although they benefit the environment, we still have to go through the whole process and show that we meet all the regulations.
And Travis, how did the salt marsh impact the construction, and what were some of the implications to that?
Yeah, so certainly working salt marshes, there's there's benefit to the tidal range. We're talking about 9-foot tides in the Boston area, significant compared to other places around the country, around the world. 9-foot tides are good and bad. It limits our growth range. We're working within the upper half of that range, but benefit of working around the tide, and certainly on this project, is that the tide goes out every day. We've got a dry window to work, whereas in contrast, when we're working on the Merrimack River, if the water's up, the water's up, and could be weeks, could be months, could be years. We dealt with that on the Merrimack River, just with a dam that was downriver, and we'll talk about that a little bit more. But on the Neponset, we chose tide windows that allowed us to work the site in the dry in the middle of the day, which is certainly the benefit. But every time the tide would come, we wouldn't work that section, and as the tide would fall, we'd chase it down and then let it chase us back up. So certainly working within that 9-foot tide window in the upper half of that, there is a dry period every day that we could do that work. So
makes for a variable work day too.
It does make for a variable work day, and having
tide.
that tide range and the dead low tide moving every day, an hour later every day, you're either starting early or you're finishing late. So
what type of innovative approaches were used for the shoreline stabilization? Verujan, can you talk about the Merrimack River project first?
Absolutely. as an experienced engineer, 45 years doing a lot of similar things, I often like to mimic Mother Nature. So I am a proponent of biomimicry in my design. How do we develop our skills from physics into structural analysis and all these things and soil stabilization? We create something that is in harmony with the environmental setting. So often I visit the areas, I look at what Mother Nature is doing, and that's what I call biomimicry. We learn from Mother Nature. Designing the river, the one in Chelmsford, was really very interesting project because upfront we had a specific constraint. We couldn't really approach it, as I said, from the top side because we had about some 1,200 to 1,500 trees that they needed to be left as they are. So we came up with this idea of the trees that we harvested to prevent any further pressure on the existing tree's root zone, which can compact it and can impact the trees. Sumco came up with the right idea of taking all the trees that were harvested, instead of taking it away, we chipped it and we spread it on the roadway, in the pathway. So occasionally we need to get some vehicular access from the top side. We couldn't do all the work from the riverside. So it was this collaboration between a designer, between the permitting. We introduced the idea to the permitting folks, and then Sumco executed the project. The end result, the client got more than what they bargained for. They got the protection of the river, which was designed to take various levels of flooding, and they got very beautiful pathway, which the community uses for walking and jogging, and that pathway is used very frequently. So that was the double benefits for the Chelmsford River project.
So Dwight, do you think there are any critical natures in these projects where just a pure living shoreline would not have been the right project approach to select, and the permitting challenges associated with that?
Yes, you know, as Varuja mentioned, you come to a site and you look at it, and you really have to approach these with a case-by-case, site-by-site design. A one-size-fits-all approach doesn't work with these types of projects. In both of these cases, we had some upland conditions which presented potential risk if these shore stabilization systems failed. On the Merrimack project, as we mentioned, there's a sewer in close proximity to the riverbank. So the purpose here is to stabilize the riverbank and to protect the sewer. So using the hybrid approach of the sill and the reconstructed bank above that gives us greater certainty that during large storm events, the bank will be preserved and protected. Even if there's some slope failure above the stone sill, that provides a foundation in protection of the bank itself and protection of the sewer. So if we had a purely soft solution, you know, we run the risk that the sewer could still be exposed if that were to erode back further. On the Neponset site, it's, as we mentioned, it's a brownfield site. So with some residual contamination, we want to make sure that that contamination wouldn't be released to the river if the shoreline continued to erode. And here, the idea is to have the salt marsh itself be the protection. So it's a nice, pretty wide salt marsh area that provides that width and length of a living shoreline to protect the upland area.
Thank you.
Eileen,
So, yeah.
I would like to add a couple of things.
Of course.
I forgot to mention it earlier. One of the challenges in the Merrimack River was because the river floods, and right now, during potential 100-year flood, the river really overflows its embankment. So in a part of the regulatory process, we had to prove to the regulators that by redesigning and building the edge, that we're not really creating the flood waters to be higher as we encroach into the river. So we did a hydrodynamic analysis of the river cross-section, proving to the regulators that after we build this, we are not going to affect the cross-section of the river to convey any given floodwaters at the same time. So that was one of the crucial things that we did. On the Neponset River, I like to mention, as we contemplated in terms of how we want to create the new salt marsh, we had some kind of a strange phenomenon going on. The Neponset River site had a lot of concrete paving and asphalt was left over from many years ago. And somehow Mother Nature created a little shallow salt marsh right on top of the concrete pavement. So we looked at it and it looked good. We said, we don't want to destroy this. So we came with the approach that we want to spade the existing salt marsh that it was growing on top of the concrete and take it out in chunks and then replant it on the site and then see if it works. And we put that as a bonus in our approach in the regulatory process. And lo and behold, it really worked beautifully. So that's what I call biomimicry in any design. It's very important. Thank you.
And just
Thank
to
you.
clarify, that salt marsh sod needed to be moved so that we could do the soil removal of contaminated soil there. So there was a section there that was paved that the salt marsh was growing on top of. The pavement needed to be removed. So we salvaged the salt marsh sod on another area on site, pinned it back in place, and it took root and is doing great.
Well, Travis, that was certainly a challenge on the Neponset site. What were some of the unexpected conditions for the construction on the Merrimack project site? And
Yeah,
how
certainly.
do you solve those?
Yeah, anytime you're working around water, it's difficult. As I mentioned, the tide comes and goes. And on a river, when water's up, the water can be up for a long time. Downstream, and this kind of plays back to that time that it takes to go from permitting, design to construction. And multiple years had passed by the time we started construction on this site. And in that multiple year span, the dam that was downriver was slated for rehab. A bladder system was installed on top of the dam. So at the original version, you can correct me if I'm wrong, but at the original design, they were planning on a water elevation that was relative to what the old dam, the wood structure on top of the dam would maintain that pond elevation. By the time construction started, several years later, the bladder project had been completed, and we were dealing with 3 to 4 foot higher water level upstream of the dam and in our work area.
Yeah.
So coming into that to begin with, we attempted to build the site as designed with the 3 to 4 foot of water, looking at access, constructability, and quickly realized that men standing in waders 3 feet deep trying to place fabric and stone to create the stone toe wasn't a possibility. So we kind of switched gears, went back to the dam owners and worked out a negotiation with them to lower water during construction. So they let water out of through the dam, reduced how much energy they could produce, what their input was for power, or what their output was for power. As a result of that, we offset that with cost to the project, and then took advantage of that window that they were allowing us with water lower than the 3 to 4 foot that we were seeing. We took this site and broke it into 6 sections, gave ourselves access to the river in 6 different sections, and put several crews out there, each working in individual sections. So during that time that the water was down, that we were paying basically for the water to be lower in order to do the work, we came at this site with multiple crews rather than one linear crew. And that was, again, working through design and permitting on where we could access the river and how we could build this. So we accomplished it by lowering the water, taking advantage of low water to do the site, and built the stone toe with low water in a very fast manner. So that was kind of one of the design elements that we hadn't anticipated, but worked through as we started the project.
Well,
Let me add one more issue. As you recall, Travis, during the process that delayed the project from the early mock-up, which we showed some of the images earlier, some of your crew standing in neck-high water and trying to implement the thing didn't work. The delay cost us about 3 months. So it pushed our construction into winter season. And now we are constructing this entire edge during freezing time. And as frost came in, we got to place fill, and we want to make sure we have no voids and things like that. So that was a little bit of challenging. We did that, and we anticipated that we're going to encounter some settlements. And in the spring, we went out and then we inspected the area. We found all these sinkholes, and we went back and filled them in and make sure that there is no further cavities in there. And we continued the project, and it was a successful effort. But that was challenging as well, doing the work during when everything is frozen.
Certainly, not only sinkholes, but also dealing with 1 to 2 feet of ice on the river. So we'd have to clear ice every day before we could start building from the bottom up. So certainly pushing that 3-month window back into winter changed our approach as well.
Yeah.
well, it sounds like there was a lot of creativity and flexibility to make that project work. What about for the Neponset project? Was there any significant, probably not as challenging circumstances for that?
Yeah, certainly every project's a little bit different. You know, tidal versus the river. Working around the tide in the Neponset, as I said, you kind of take advantage of the low tide windows. We were working kind of on the back side of a bulkhead and didn't want to, as Varujan had mentioned, didn't want to be removing that wood and exposing contaminants into the river. So we left as much of the bulkhead as was stable in place and used that as the toe for our new living shoreline there.
Well, thank you. All right, so all of you, as a wrap-up, I'd like to ask each one of you, what advice do you have for others embarking on similar types of projects? Dwight, could you please start with permitting issues?
Sure. The permitting, let me start that, you know, basically, we need to start with teamwork from all the parties involved throughout the project life cycle. But with permitting, and that continues through the project life cycle too, we start with pre-design work, and that includes having pre-applications with the multiple agencies from which we'll need permits and approvals to begin construction. And having a pre-application phase puts it in an informal situation and discussions with the permitting agency staff. So we can have open discussions about options, alternatives, what their issues and concerns are with the project. We can then work with the designers, with the engineers to address those concerns and issues up front so that when we come into them with the application package, we've addressed those things up front, and it helps to move the process more efficiently. During the design phase, the environmental folks, the permitting folks, whatever you want to call them, work with the engineers and the designers to make sure that all of the elements that are identified by the regulatory folks are incorporated into the engineering design. And in these cases, we're often talking about ecological elements, not just stone and concrete, but working to make sure we have the right plant palettes and things like that. And then during the construction phase, as Travis mentioned, there are oftentimes field changes that need to be done that might require going back to the permitting agencies to get buy-off on those field changes. And that takes a lot of teamwork because we want that to happen quickly. Travis's folks are out there, and if they're not working, they're still out there, and there's a lot of money at stake during construction. So having that teamwork with the agencies so that they can anticipate coming back for permit modifications during the construction phase. So those are some of the things that I on the permitting side that people should think about for these types of projects.
And Verusian on the design and engineering recommendations and advice?
Yes. As an engineer, I always like the process of collaboration. Collaboration is absolutely an important process in coming out with the best results. No matter how good one person is within their own discipline, you don't know all of the answers. We always say, bringing more minds to the process always provides the best results. In any project I do these kinds of things, I always consult with our ecologist, and I would talk to our permitting folks, and even I called contractors in terms of what's the best way of doing this, what is the limitation, what they can do and what they can't do. And often, even if Travers is not involved on one of the projects I'm doing, I do call them and I said, how about we have a cup of coffee? I like a couple of ideas I'd like to run with you, because contractors are a very resourceful people. They know where to source the material in, and they can give you early ideas that you can incorporate in the design. So that's an important process. I'd like to mention one thing that we forgot to say. As we continue to improve the project, and it's began to look very good with the green grass and the salt marsh and all that's coming, some of the regulators, came in at the project and they said, what's all these 600 sticks out in the mud, which was all the old piles was left over from the old dilapidated pier that was gone a long time ago. And so they forced us to do a study. They wanted us to really take them out, pull them out of the water. We said, we don't want to do that. So we did a study and we convinced them taking those piles out is going to stir the mud and release all the contaminants in the water column. And the final winning point was those sticks are a wonderful art piece in the river where the birds can really find the perching places. So they couldn't argue with that concept. So we won the case.
Excellent. And Travis, what advice do you have for someone undertaking similar projects?
Yeah, similar to Verusian and Dwight, teamwork and collaboration are two key elements to any of these projects. None of them go exactly as they're planned. There's always the design changes. There's always things you need to overcome as you're getting into the project. Having that open dialogue from the beginning, doing a mock-up like we did at the Merrimack site, realizing that 3 to 4 feet of water wasn't workable to do 4,000 feet of riverbank, and then being able to come back to everybody and say, okay, let's get our heads around this. How do we make it so that it is constructible? What are our options? And that collaboration, having a good team to begin with, isn't something that you get on every project, but these are two specific projects where the team was able to work together, and that team being together is what made these both successful projects. So having that teamwork and that collaboration, that open communication between permitting, design, and the contractor, having everybody on the same page and being able to modify and make those changes as we go was paramount.
Well, I want to thank you all. This has been a fascinating discussion. I think you all really did emphasize how important teamwork is and collaboration is for the success of the project. And I also want to thank our audience for joining us in this discussion. Please feel free to reach out to any of us if you have any other questions about any of these projects. And thank you.
Thank you.
Thank you very much.